Hi algebra students, this is our introduction video for our lesson on building quadratic functions for geometric patterns. So starting with that vocabulary, in yesterday's lesson we had talked about this new relationship we're going to be looking at, a quadratic. And we said a quadratic is going to be anything that's in this form, ax squared plus bx plus c, with the most important part of that being that x squared term. In a quadratic, you will always have a squared term. We've learned maybe the variables are different. Maybe instead of x squared, you see a squared, n squared. Maybe there's a number in front of it, like 2a squared, but you're always going to have that squared term. And that squared term matches up in patterns with something that looks like this. Maybe for step 1, you see a square that's 1 by 1. Step 2, you see a square that's 2 by 2, and then for step 3 you see a square that's 3 by 3. We had talked about these quadratics, and patterns look like a square that's getting bigger and bigger with each step number. And so if I asked you to represent this for step x, it would be a square that is x tall and x wide, and then our total number of squares in it, instead of 1 times 1, 1, 2 times 2, 4, 3 times 3, 9, your total number of squares would be x times x, or x squared, hence the squared term. In yesterday's lesson, we also saw with quadratics, you can change this a little bit. So maybe every single time I add one extra square, then my pattern would be x squared plus 1. And so that's where you can get these other terms in your quadratic. The focus of today's lesson, we're going to continue looking at these patterns, but look at patterns that are a little more fun, where that extra stuff, those extra terms, might be a little more challenging than just adding one square every single time. And so to give you an example of the patterns we are looking at in this lesson, I've got this one right here. Now, instead of calling them step numbers, they're calling them stages. So this is stage 1, stage 2, stage 3. I'm going to have you go ahead and pause the video, and I want you to think about what would stage 4 look like and what would stage 10 look like for this pattern. Being able to predict future ones is a great way for you to check and see, did you identify the pattern? Go ahead, pause the video here, and then come back to see if you got it. So as we look at this pattern, some strategies we had talked about in the previous lesson is seeing if you can find a connection between the step or stage number and the picture. So looking at the image here, if I can describe it with the number 1, if there's any way for me to describe this picture using the number 2, any way for me to describe this picture using the number 3. And as I look at that, I start to see that the height every single time is the same number. So here I have a height of 1, here I have a height of 2, here I have a height of 3. And so that helps me when we get to stage 4, I know that it's going to be 4 squares tall. And when we do stage 10, I know it's going to be 10 squares tall. Now in yesterday's lesson, we were talking a lot about squares, but here these are not squares, these are rectangles. And so I'm noticing the length here is 2, the length here is 3, this is 4. So I've got different numbers. But I start to notice again a pattern. Do you know how long this one would be? It's going to be 5. What about this one? That one's going to be 11. And you start to notice that every single time this top number here is just 1 more than the step number. And so for step 4 or stage 4, it's 1 more than our stage number. For stage 10, it's 1 more than our stage number. And so for stage 4, you would have a rectangle that's 4 by 5. And for stage 10, it would be a rectangle that's 10 by 11. Now, this means I know this pattern, but one of our focuses for this lesson is, can you represent it using some sort of expression? And one way we can think about this is if I were to change this to stage stage N, do you know what that rectangle looks like? Well, for stage N, we keep saying the height is the same as that number. And so the height of this rectangle would be N tall. And then the length, we keep saying it's one more than our stage number. So our length here would be N plus 1. So we would have a rectangle like this. And so if I wanted to know how many total squares there are in this rectangle, what math would I need to do? Well, for these other ones, for example, stage 3, I could do 3 times 4. For stage 4, I could do 4 times 5. Stage 10, I could do 10 times 11. I'm just multiplying those two sides. So for this one, I could do n times n plus 1. And there is our expression for the total number of squares. Now, we just said above, quadratic expressions are always going to have the square that's getting bigger and bigger. In this pattern here, we just said it's not a square, it's a rectangle. And so why are we talking about this pattern in today's lesson? Well, if you look at this picture a little differently, you can see how it relates. In this picture, I can make squares. If you focus in on that blue part, we do have a square that's getting bigger and bigger and bigger. That extra amount is, instead of like one extra square, here it's one extra row, which is making it a rectangle. And so this is what I meant by those extra terms being a little more challenging to see. But this is still a quadratic because we have that square getting bigger and bigger. In today's lesson, we're going to be focusing on patterns that look like this, as well as coming up with those different expressions to represent them. You are ready for today's lesson.